Jai Hind. Today we are doing maths. Some interesting problem. 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9. The trick is counting the number of term 1, 2, 3. So we write numerator 3 and we write first number that is 3 and last number that is 9. So 3 cancel. So 1 upon 9 is the answer. So what we do, we first check the difference should be equal. 3 to 5 2 difference, then 5 to 7 2 difference, then 7 to 9 2 difference, and we see the last number 5 comes in the next term first number. This pattern is following to find the sum. Now let us do one more problem. Find the sum. 1 upon 3 into 5, 1 upon 5 into 7 plus 1 upon 7 into 9, 1 upon 9 into 11. So find the sum. There is how many term? 4. 1, 2, 3, 4. So we write numerator 4. We write denominator 3, first number, and last number is 11. So 3 into 11 is 33. We write it denominator and numerator is 4. 4 upon 33 is the answer. If we want our old method, that is called LCM method. So in LCM, we first solve the fraction, that is 3 into 5, that means 15. So 1 upon 15 plus 5 into 7, that means 35. So 1 upon 35 plus 1 upon 7 into 9. 7 into 9 is 63. So 1 upon 63. LCM of 15, 35 and 63. So LCM is, there is 315. This after taking 315 LCM, divide 315 by 15, we see we get 21. So 21 1 ja 21 plus 35 divide 315, we get 9 plus 63 divide 315, we get 5. So 21 plus 9 30, 30 plus 5 35, 35 upon 315, it will give us 9. 35 9 ja 315. So 1 upon 9 we can get the answer. So what we see, the last number of the first term is first number in the second term denominator. Similarly 7 is there, similarly 9 is there, and difference is 2 everywhere is there. So we can write number of terms in the numerator and first number and last number of denominator we write in denominator. So 3 into 11 we write in denominator. So 3 into 11 is 33. 4 upon 33 is the answer. So this second question by LCM is quite large. So it is not possible. If we increase the number of terms, the possible of LCM is impossible, like structure. Next problem we are doing for practice. 1 upon 2 into 5 plus 1 upon 5 into 8 plus dot means multiply 1 upon 8 into 11 plus 1 upon 11 into 13 plus 1 upon, there is a gap 3, so 11 to 14, then 1 upon 14 to 17, 3 gap, then plus 1 upon 17 to 20. Can we check the answer? You can pause the screen and find your own way to get the answer. First, what we write in numerator? Number of terms 1 2 3 4 5 6. So we write 6 in numerator. Then we check the gap. Gap is 3. 2 to 5, 5 to 8 gap is 3, 8 to 11 gap is 3, 11 to 14 gap is 3, 14 to 17 gap is 3, 17 to 20 gap is 3. And so, and last number 5 is there, then last number is 8 is there in the first term, first number, then 11 is there in first number, then 14 is there, then 17 is there. So we write first number, that is 2 in denominator, then last number, that is 20. So 6 upon 2 into 20, that means 40. So 6 upon 40 cancel by 2. We get 3 by 20 as answer. Now this trick gives us quite simple method, quite easy technique. Now similar one more problem we are practicing. So this type of question generally asked in competition exam like SSC. So this is important for practice. So 1 upon taking the number 1 upon 1 into 5, there is a gap 4. Then 1 upon 5 into 9, gap is 4. Then 1 upon 9 into 13, gap is 4. Then 1 upon 13 into 17, gap is 4. Then 1 upon 17 to 21, gap is 4. Similarly 5 is available in the next term, then 9 is available in the next term, then 13 is available next term, then 17 is available in the next term. So what we write now, number of terms 1 2 3 4 5. So 5 we write in numerator, and denominator we write first number, that is 1, and last number, that is 21. So 21 1 ja 21. So 5 upon 21 is the answer we get. Next problem is 1 upon 2, 1 upon 2 plus 1 upon 6 plus 1 upon 12 plus 1 upon 20 plus 1 upon 30. Now in this question, this is the basic question. So we convert first, do not take LCM, we convert into factors. Now after converting into factor of 2 is 1 into 2. So we check is 2 is divisible, can divide 6, yes, 3 times. So 2 and 2 3. And now check 3 divides 12, yes, 4 times. So we write 3 into 4. Now check 4 divides 20, yes, 5 times. So we write 4 into 5. Now check 5 divides 30, yes, 6 times. So we write 5 into 6, that means 30. So after converting into this type, previous type question, we have to find the factors. But look, the 2 is there available or not. Now 3, then 4, then 5. Now check the gap. 1 is gap, 1 is gap, 1 is gap here, 1 is gap here, and 1 is gap here. So our fulfillment is there. Now using our previous method, we count the number of terms 1 2 3 4 5. So we write numerator 5, and in denominator we write first number, that means 1, then last number, that means 6, and in denominator 1 into 6 is 6. So 5 upon 6 is the answer. Next we are taking example 1 upon 30 plus 1 upon 42 plus 1 upon 56 plus 1 upon 72 plus 1 upon 90 plus 1 upon 110. So now again previous type question, first our duty is to make a factorize such that we get a previous type pattern. So 30's factor is 5 and 6. So smaller number first we write, then larger number. Now 6 divides 42 7 times. So we write 42, 6 into 7. Then 7 divides 56 8 times. So 56 is written as 1 upon 7 into 8. Then 72 is written as 8 divides 72 9 times. So we write 8 into 9 plus 1 upon 90 divides 9 10 times. So we write 9 into 10 plus 10 divides 110 11 times. So we write 10 into 11. So after writing 8, now we count the number of terms 1 2 3 4 5 6. So 6 is written in numerator, upon we write first term, that means 5. We write last term, that means 11. So in numerator we write 6, in denominator we write 5 into 11, that means 55. So 6 upon 55 is the answer. So next problem, basic problem. Again we write 1 upon 12, then plus 1 upon 20, then plus 1 upon 30, then plus 1 upon 42, then plus 1 upon 56, then plus 1 upon 72, plus 1 upon 90. In this question, first is again we find the task, the factors of 12 of denominator in the first term denominator. So 12 factor is 3 into 4. So we write 12 as 3 into 4. Now this 4 divides 20 5 times. So 20 is written as 4 into 5. So this 5 divides 30 6 times. We write 5 into 6. Then plus 6 divides 42 7 times. We write 6 into 7. Then 7 divides 56 8 times. So we write 7 into 8. Then 72 divides 8 9 times. So we write 72 8 into 9. Then 9 divides 90 10 times. So we write 9 into 10. Now look, 3 into 4, 4 into 5, 5 into 6, 6 into 7, 7 into 8, 8 into 9, 9 into 10. So last number of first term is first term of second term in denominator. Same pattern is we see in all denominator terms. And gap, here gap is 1. In second term gap is 1, third term gap is 1, fourth term gap is 1. Everywhere gap is 1. So again, according to our previous questions, we write number of terms in numerator 1, 2, 3, 4, 5, 6, 7. 7 terms we write here. So 7 is in numerator. In denominator, first number that means 3 and last number that means 10 we write. So 3 10 is 30 we write in denominator and 7 we write in numerator. 7 upon 30 is the answer. I hope you are understanding very well. Next problem is 1 upon 1 into 2 into 3 plus 1 upon 2 into 3 into 4 plus 1 upon 3 into 4 into 5 plus 1 upon 4 into 5 into 6 plus 1 upon 5 into 6 into 7 plus 1 upon 6 into 7 into 8. So this type of pattern we are writing here. Now look, there is the pattern and 1 2 3, there is 3 numbers. This is 3 terms number and this is important. So first we know about its general formula. It means solution. So its solution is we write 1 upon 4. This is fixed. 1 upon 4 always we write. Then we write in numerator last term's number. Last term number is 6 7 8 in denominator. So we write 6 in numerator, then 7 in denominator, then we write 8 in denominator again, then we write 9. It means consecutive numbers 6 7 8 9. This we write 9 in written in numerator. So this is the answer of this series. Solution gives us 1 upon 4 into 6 9 is 54 upon 7 8 is 56. 4 cancels by 2. So we get 27. 4 cancels by 2 times and 2 into 56 is 112. So 27 upon 112 is the answer. Now look the general formula. If this above series is till how many terms? N terms. Then we write general formula, this series, then last is n plus 1, n plus 2. This general formula tells us, first we write 1 by 4, then multiply, then we write n, last terms denominator n, then n plus 1, then n plus 2, then n plus 3. This is the general formula for solution of this type of pattern. So practice, you make it more, practice it. I hope you can do very well in the next time this type of problem. Okay.